Hello everybody, welcome into another lesson. So today we are going to talk about 5 ways to prove that a quadrilateral is a parallelogram. So yesterday we talked about properties of parallelograms. Today we're going to have converse definitions and theorems of yesterday's definitions and theorems. The first way is, well, by definition. If both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram, and that's by definition. If we remember, the definition of a parallelogram is a quadrilateral that has both pairs of opposite sides parallel to each other. So this is simply the converse. If both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. So that one shouldn't be too bad. Alright, now we have 4 new theorems. Here is a new theorem. This theorem states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So yesterday we talked about how in a parallelogram both pairs of opposite sides are congruent to each other. That was the theorem we had. Well, this is now the converse theorem of that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Alright, that one was easy enough. Let's move on to the next theorem. This theorem is that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So yesterday we also had talked about that in a parallelogram both pairs of opposite angles are congruent to each other. Well, here we have the converse. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Alright, I have another theorem here. This one is a little bit different. Alright, so this theorem states that if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. So we didn't quite have a converse to that yesterday, but this is almost intuitive. So to repeat that, if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. And we're going to put all these into practice here in just a minute. I got one more theorem. It'll be a converse to one of yesterday's. Okay, so the last theorem for today is that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So yesterday when we talked about parallelograms, we talked about how the diagonals of a parallelogram bisect each other. Well, we have the converse of that theorem here today, and it states if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So all this was learning the converses of yesterday's lesson. We're going to use these here for the next 9 exercises to determine, let's see, determine if A, B, C, D is a parallelogram. So we're going to determine if quadrilateral ABCD is a parallelogram in these next 4 exercises. Well, I shouldn't have an up curve there. So A, B, C, D. So here is our first quadrilateral. Let's see what information we've been given. See, this side has length 8, so does this side. This side has length 12, and so does this side. Okay. So let's look at quadrilateral ABCD. Immediately we notice that both pairs of opposite sides are congruent to each other. So the answer is yes, this is a parallelogram by both pairs of opposite sides congruent. So since we notice that both pairs of opposite sides of quadrilateral ABCD are congruent to each other, then yes, quadrilateral ABCD is in fact a parallelogram because both pairs of opposite sides are congruent. So that's putting these into practice. All right, what's next? See, we have A, B, C, D. What else do they give us? We have 2 diagonals here. All right. We are given that this side is parallel to this side. This side has length 9, this side has length 9, and that's all we're given. So here we have quadrilateral ABCD with diagonals. Well, side AB is parallel to side CD, and both of these sides are congruent. Is that enough to determine if this quadrilateral is a parallelogram? Yes. It is, because one pair of opposite sides is both parallel and congruent. So since we have this quadrilateral here that you have one pair of opposite sides that's both congruent and parallel to each other, then yes, we can actually say ABCD is in fact a parallelogram. All right, what do we have? Okay, we got diagonals here, 2 diagonals. That much has been established. Now, what else do they give us? they give us that AB is congruent to CD. Oh yeah. This here where these two diagonals intersect is point O, okay? They also give us that AO is congruent to CO. And that's all they give us. Well, let's start here. We know that AB is opposite CD, and that's congruent. They're congruent to each other. We know that diagonal AC is definitely bisected here at point O, that because you have AO and CO congruent to each other. However, here's what we don't know. We don't know if AD's congruent to BC. We don't know if diagonal DB is bisected. In other words, we don't know if DO is congruent to BO. We don't know if any of the angles are congruent or not, or supplementary. So we actually have no way to determine if ABCD is a parallelogram. So you might want to say no determination possible. In this particular case, we don't have enough information to determine that. So no determination is actually possible for this particular quadrilateral to determine if ABCD is a parallelogram or not. All right. Another one. A, B, C, and D. What else are we given? Diagonals. Let's see what else they give us here for this particular case. Well, it would help if I list my points, right? Where the two diagonals come together at point O. In this case, they give us here AO is congruent to CO. They even give us that DO is congruent to BO. All right? So in this case, it's clear to see that both diagonals actually bisect each other. So yes, it would be true that ABCD is a parallelogram in this case. Yes, because both diagonals bisect each other. So, yes, we can actually determine that quadrilateral ABCD is in fact a parallelogram, because if you look at both diagonals, they're both split into two congruent parts on each one, meaning they bisect each other. So yes, this one is a parallelogram. Okay. Actually, let's change the drawing of that a little bit. Okay, so with this particular one, well, I better label the points. That would sure help. A, B, C, and D. Alright, so there's quadrilateral ABCD. What do they give us? They give us that angle D is 70 degrees, and they also give us that angle B is 70 degrees. Okay. So Angle D is 70, angle B is 70. Well, that's all fine and dandy. We know that one pair of opposite angles is congruent, right? Well, we know nothing about any of the sides, if any of them are parallel to each other, congruent to each other. We have no diagonals to work with. And we don't know anything about angles A or C. So in this case, no determination is possible. We actually have no way to determine if quadrilateral ABCD is in fact a parallelogram, mainly because if we're going to go based off angles, we know nothing about the other angles. We know nothing about parallel sides or not. We know nothing about the sides congruency, so we have no diagonals to work with, so no determination is possible in this particular case. However, what if we change it ever so slightly? We add, for the next exercise, that angle A is 110 degrees. Okay, well, what do we have now? Let's look at something here. Right away, it may not seem possible to prove it still, but if you notice, angle A and angle D are supplementary, right? If you take 110 and 70, they add up to 180, meaning that they're supplementary angles. If you have two lines here, AB and CD, that are cut by a transversal, such as AD right here, that could only mean then, if the same side interior angles are supplementary, that they're parallel to each other. So now we have identified that AB is parallel to CD, which would in turn enable us to determine angle C. If AB is parallel to CD, which we now know, that means BC is the transversal, and the same side interior angle C would be supplementary to 70. If you subtract 70 from 180, you get that angle C is 110. And what do you know? You now have both pairs of opposite angles congruent to each other. So, based on that, yes, ABCD is a parallelogram. The answer is yes, both pairs of opposite angles are congruent. So this is where past theorems and definitions can also really come in to help you. So since both pairs of opposite angles are congruent in this particular quadrilateral, yes, it's true, ABCD is in fact a parallelogram. Okay, so what's next then? Another interesting one here. A, B, C, and D. Okay, that's what we have so far. We have here that both angles C and D are right angles. We do have that. We even have here that AB is parallel to CD. Well, there's a couple ways you can go about it. In the end, it's going to be true that we can prove that ABCD is a parallelogram. Let's go about it the first way. The first way you're all probably thinking of is angles, right? If AB is parallel to CD, that means AD is the transversal, and same side interior angles are supplementary. The supplement to 90 degrees is also a 90 degree angle. So that would have to mean that angle A is a 90 degree angle. And then AB is parallel to CD, well, that also means then that BC is a transversal there. Angle B is the same side interior angle to angle C, which means they're supplementary. The supplement to 90 degrees is also 90 degrees. So angle B would even be a right angle. So one way you can say this is a parallelogram, of course it is. You have both pairs of opposite angles are congruent. That's one way to say this is a parallelogram, but you know we didn't even have to go through all that with the angles. There was something even simpler. There's an even simpler theorem. We could forget the fact that angles A and B are right angles. We don't even need that. Why? Remember that theorem from not too long ago that says that two lines perpendicular to the same line are parallel to each other. So two lines here, AD is perpendicular to CD, and BC is perpendicular to CD. That means that they're parallel to each other. So AD is parallel to BC. So on the basic definition of a parallelogram, you can also say that yes, it's true that quadrilateral ABCD is a parallelogram. Both pairs of opposite sides are parallel. So that's another possibility for proving that ABCD is in fact a parallelogram. So take your pick however you choose to do it, but a lot of people, including myself, I used to forget that theorem, that if two lines are perpendicular to the same line, then they're parallel to each other. That's going to make your life so much easier, especially when dealing with parallelograms. Okay. Let's go on to the next quadrilateral here. A, B, C, D. We have a diagonal going from B to D. Okay. What else? AD is congruent to BC. We're given that. We're even given that angle ABD is congruent to angle CDB. So we have here now also that angle ABD is congruent to angle CDB. Okay. So let's establish something here. Let's use the fact here that we have two congruent sides. Well, if these two angles are congruent, that means they're alternate interior angles, aren't they? They're alternate interior angles because BD is the transversal. If you have two alternate interior angles that are congruent, that means the two main lines are parallel. So we can now even determine that AB is parallel to CD. But does that help us get anywhere? Is that going to help us get anywhere? Well, let's see. I don't think you have we can't assume it's a parallelogram. We can't assume it's a parallelogram. In fact, we can't even assume that the two triangles it's split into are congruent. We have no way to know if they're even congruent. So in this case, It's great that we know we have two parallel sides, but no determination is possible. So sometimes you can do a little bit of work to try and see if it's going to be a parallelogram, but we actually don't have enough information to determine whether or not quadrilateral ABCD is a parallelogram, because we know nothing about the other angles. We have no clue about them. I know some of you are going to go for, well, wouldn't angle C be congruent to angle A since they're opposite angles? Well, if we could know for sure that ABCD was a parallelogram, that would be true. But we don't know that. We can't assume that. All right. A, B, C, D, diagonals on each. We have two diagonals here. So what do they give us? What do they actually give us? They give us here the fact that we have alternate interior angles that are congruent, so that's a start. We do have alternate interior angles that are congruent. And actually, this is really going to help. Let's start here with angle ABC and then angle DCB. We can clearly see they're alternate interior angles, right? If alternate interior angles are congruent, then that means the opposite sides are parallel. So AB, we can say for sure now, is parallel to CD. So that's going to help a lot already. Now, I can tell you, you don't want to go off of angles because we know nothing about angles A and D at all, or any parts of them. But let's look here at angle ACB. And then we have angle DBC. Those are also alternate interior angles, right? And BC is the transversal, which would also mean that AC is parallel to BD. Well, what do you know? Both pairs of opposite sides of this quadrilateral are parallel to each other. So by definition, yes, ABCD is a parallelogram. Yes, both pairs of opposite sides are parallel. So yes, we actually can soundly conclude that quadrilateral ABCD is a parallelogram because both pairs of opposite sides are parallel. All right. So for these ones, we just determine whether or not a quadrilateral is a parallelogram. Now, for the next 4 exercises, it's going to be a little bit different. I'll explain. These are some algebra geometry problems again. We have 4 of them to do tonight. So what is the objective here? What values must X and Y have to make the quadrilateral a parallelogram? Okay. So we're about to try to figure out, we're going to have 4 exercises here where we're given quadrilaterals rather. I almost just assumed that they were quadrilaterals, I mean, well, they're definitely quadrilaterals. I almost assumed that they were parallelograms, which we don't want to do that yet. Not till I give you the information. No labeling of sides. We just have here, this angle is 8x minus 6. This angle here is 42 degrees. This angle here is 3y. Okay? So we need to basically determine what values of x and y will we need to make this quadrilateral parallelogram. So when you do exercises like that, you operate under the assumption that this is a parallelogram. That's the best way to do it. Operate under the assumption that this quadrilateral is in fact a parallelogram. Well, right away we can solve for y, because if this is a parallelogram, then opposite angles are congruent, right? So you're just going to take that 3y, set it equal to 42 degrees, which would have to mean that y equals 14 degrees. So the value of y would be 14 degrees. All right, that was easy. Now what about solving for x? If this is a parallelogram, that means that these two sides are parallel. This is the transversal, meaning this angle is the same side interior angle to the 42 degrees. So what we have to do now then is subtract 42 from 180. So 180 degrees minus 42 degrees would equal 138 degrees. So the missing angle here is now 138 degrees. And if this is a parallelogram, then these two angles are congruent. So that means 8x minus 6 equals 138 degrees, which would mean 8x equals 144 degrees. Then x is just 144 divided by 8. Which would be 18. So the answers we end up getting for this exercise is that x is 18 degrees and then y is 14 degrees. So for these types that we're doing, for this and the next three that we're going to do, you would operate under the assumption that the quadrilaterals are parallelograms to solve for the variables. All right. And I believe, yes, we do have two diagonals. Perfect. All right. What else are we given here? Good one. This is a real good one. This half of this one is y squared. This half here is y plus 30. Okay. This half here is 3x. Is that right? Yeah, it's right. 3x minus 40. This half here is just x. Okay. So we have the lengths of the diagonals measured out, right? If we're going to operate under the assumption that this quadrilateral is a parallelogram, that simply means that the diagonals bisect each other. So in other words, each half is equal to the other half. So that means to start, we'll solve for x at 3x minus 40 equals x. So 3x minus 40 equals x. Well, that's going to give you that 2x equals 40, which would then just give you that x equals 20. So x wasn't so bad to solve for. X is 20. Now, we got to deal with this other diagonal. Still, they would bisect each other, meaning that each half is congruent to each other. So what you would do next is to solve for y, set y squared equal to y plus 30. Which would end up changing into y squared minus y minus 30 equals 0. Now we have a quadratic equation to solve, which would end up factoring into y minus 6 times y plus 5 equal to 0, right? So yeah, y squared plus 5y minus 6, that's minus y minus 30. Perfect. So I factored it just right. This factors into y minus 6, that quantity, times y plus 5. And initially, you'll get two solutions for y. You would get that set each one equal to 0, you get y equals 6, and then y equals negative 5. Well, if this were just a standard algebra problem, you would keep your two solutions. But this is geometry. In geometry, there really isn't such a thing as negative length. Now, when you get into trigonometry and algebra 2 trig, that's a little bit different. But even then, the length isn't truly negative. The negative sign would just indicate which direction something's going. But for this course, we're going to discard all negative solutions for length. So the only possible solution you could have then is that y equals 6 because it's positive. So what you get in the end is that x equals 20 and y equals 6. So that was actually a good quadratic equation review. That's why I love doing these problems, because it helps us to keep up on our algebra. Two more problems here. Oh, these will be good too. These are going to be good also. Alright. What else do we have? Okay, no diagonals for this one, so that's nice. So 42 here, 4x plus y here, then we have 26 here, and then 3x minus 2y for this side. Alright, so again, we want to solve for the values of x and y that would make this quadrilateral a parallelogram. So we need to assume that this quadrilateral is a parallelogram to be able to solve this. Well, what do we know about the sides of a parallelogram? That both pairs of opposite sides are congruent. So you would start with 3x minus 2y. Whoops, let me write a different color. Start with the fact that 3x minus 2y would equal 26, right? Then the next fact that 4x plus y would equal 42. Okay? Well, this isn't quite as easy to solve as the ones we had yesterday, but if we take the second equation and multiply that by 2, what you end up having now with the new system is 3x minus 2y equals 26, and then you would have 8x plus 2y is equal to 84. So if you multiply the second equation by 2, you end up getting the second equation is 8x plus 2y equals 84. Now if we look at the y terms on each equation of this system, we can actually add these equations together now, and the y term will cancel out to solve this system of equations for the x variable. So we add these together, you get 11x, the y's are gone, is equal to, what's 84 plus 26? That should be 110. So we get 11x is equal to 110, which would just have to mean that x equals 10. So the x value for this equation would be 10. Now we know to solve for the other variable in a system of equations, go ahead and put that x value into one of the originals. I'm going to go with that 4x plus y. So take 4 times your x value of 10 plus y, set that equal to 42 from your original equation. That would mean you get y plus 40 equals 42, which would just have to mean then that y equals 2. So the answer you should get here is that x equals 10 and y equals 2 once you solve this system of equations. Alright, I got one last problem, then we're done for the day. And guys, there is no shame in this. I just want to say this. If you're struggling with any quadratic equations, how to solve them, or systems of equations, or really anything from algebra, please check out all my Algebra 1 videos. I did teach Algebra 1 before geometry, as probably most of you are well aware. So please check those out. If you're struggling, the reason I'm not really fully reteaching the algebra is because there's no time in geometry, okay? Because geometry, as you've already seen, is enough to cover in and of itself. It's kind of assumed that you've already had exposure to Algebra 1 and you've completed that. So I have no problem reviewing algebra, I just simply don't have time to fully reteach it. But all my videos from Algebra 1 and even before that, they're on YouTube. They are free, no cost to you. Check them out anytime. Okay, last problem here. We just have one diagonal, which is going this way. Alright, what do we got here? This is 7y minus 2. This here is 3x. This here is 9y. This angle here is 4x plus 1. Alright, so we got all of our angle measurements. Well, let's do a couple things here, okay? In order to solve this, we have to temporarily at least assume that this quadrilateral is a parallelogram. Based on the definition of parallelograms, we know that both pairs of opposite sides are parallel. So let's go ahead and draw our parallel markers, right? So we're acting like this is a parallelogram, meaning that if two lines are parallel, they're cut by a transversal. Look, each of these here are alternate interior angles. And we know that if two lines are parallel cut by a transversal, that alternate interior angles are congruent. So let's start here with 3x would equal 7y minus 2, right? Those would be congruent because they're alternate interior angles. Next, you would have that 4x plus 1 is equal to 9y. Right? Okay. Let's get the x's and y's on the same side and get the constant over on the right. So for the first equation, this would turn into 3x minus 7y equals negative 2. And then this would turn into 4x minus 9y equals negative 1. I know, this just got a little bit hairy. Well, substitution sure as heck isn't going to be easy. You can't just add anything and eliminate it right away. You're going to have to do some multiplication on each variable. The thing is, do you want to cancel out the x variable or the y variable? Well, I think it's going to be a lot easier if we go for the x variable to cancel out with this system, because you'll work with smaller numbers that way. So what we're going to do then is take the top equation, multiply that by 4 to make that a 12x. We'll take the second equation, multiply that by 3 to make that a 12x. Let me move this over here actually so you can see it better. If we take these and multiply them, you'll end up getting 12x minus 28y is equal to negative 8. You'll also get then 12x minus 27y is equal to negative 3. So now I think it's obvious that we can cancel the x variables. So let's subtract the second equation from the first. If you do that, the x's go. You'll have negative 28 minus negative 27y, which would become negative 28y plus 27y, which means negative y is equal to negative 8 minus negative 3 turns into negative 8 plus 3, which would be negative 5. So negative y equals negative 5, which means y equals 5. Alright, so we've now just determined that y equals 5. Well, all we have to do now to solve for x is put that y into one of these original equations. So let's go ahead and do just that here. I'll go with 3x equals 7y minus 2. If we do that, you'll have 3x equals 7 times that value of y, which was 5, minus 2, which then means that 3x would equal 35 minus 2, which then means that 3x equals 33, which then means that x would equal 11. So the values of x and y that we need to determine if this quadrilateral is a parallelogram, you would get x to be 11 and y to be 5. So that's it for this lesson. Next lesson, we're going to have some important theorems involving parallel lines. So I hope everybody has a good night and take care.